chapter 10, I think. We've been talking about acid and bases, again, sort of the last chapter that really involved calculations. So last time we talked about acids and bases. We also got into doing some calculations as to help us figure out whether or not a solution is going to be acidic, basic, or neutral. And we could do that by using what is commonly referred to as Kw, and that is the concentration of H plus times concentration of OH minus equals 1 times 10 to the minus 14. And we really use this as sort of a conversion. It's really the same calculation regardless of which one you're given. Remember that the H plus is sort of like the acid part of the solution. The OH minus is really the base part of the solution. So depending on which one you're solving for, again, it really is the identical calculation. And as we talked about, you want to definitely make sure you are using your exponent button with these. Otherwise, you will find yourself off. And what we can do is obviously when we do calculate these guys, we could compare the two concentrations. And if the H plus concentration is larger than the OH minus, really the acid part is larger than the base part, it would be an acidic solution. If the OH minus is larger than the H plus, then the basic part of the solution is more. And lastly, if they are equal to each other, they will equal 1 times 10 to the minus 7, and it would be a neutral solution in that case. They do go opposites of each other. So as the concentration of H plus increases, concentration of OH minus decreases, and vice versa. As one goes down, the other goes up, basically. And lastly, remember in acid-base chemistry, H plus and H3O plus is pretty much identical to each other. So you'll sometimes see this formula for Kw written H3O plus times OH minus is equal to 1 times 10 to the minus 14. The other important thing we talked about is remember that the sort of smaller negative exponent is the larger number, and that's a very common mistake people make when they go to compare it. So that negative is important when you have it. Any questions on any of that stuff there that we talked about? Okay, so I think we're right in the middle of an example. I think we did the first one, if I'm not mistaken. I think last time we did this first one. So why don't you then go and do these three here. So you're going to solve for the H plus concentration or the OH minus concentration for each of those individually, depending on which one is given to you. And then you want to determine, is it acidic, basic, or neutral? So take a couple of minutes, make sure, again, you take your calculator, you know how to punch it in correctly. So for each of these following three, determine the other concentration and is it acidic, basic, or neutral. Okay, let's take a look, see how you're doing. So again, I think we did the first one. So we'll take a look at the second one there. So as we talked about, regardless really of which one you're given, it really is the same calculation. Again, we want to use our Kw, which is our H plus and our OH minus, going to equal 1 times 10 to the minus 14. That means in this particular case, we would be looking for the OH minus concentration, which would be 1 times 10 to the minus 14 divided by 2.6 times 10 to the minus 8. Remember, when you punch this in, you want to do something like 1 exponent button, negative button, and 14, divide button, 2.6, exponent button, negative, and 8, and then hit equals, and you should be hopefully in business on that. Let's see here, 1 exponent negative 14 divided by 2.6 exponent minus 8. It looks like on my calculator here, I get 3.8 times 10 to the minus 7. This would be molarity as it is a concentration. First off, any questions on that calculation? Remember, when you hit the exponent button, it stands for the times 10 part, so no need to hit the multiplication button or any of those things along the way. In this case, the H plus concentration is less than, right, the OH minus concentration. That means that this solution should be basic. Again, Looking at 10 to the minus 7 versus 10 to the minus 8. Again, that negative is important because it's going this way with zeros. So the bigger the number there, the more zeros, which means it's actually a smaller number in this particular case. Any questions on any of that calculation there on that one? Okay. So let's take a look at the next one, which I think is an OH minus concentration that's given to us. So again, doesn't really matter, still going to basically end up the same. This could be H plus is equal to 1 times 10 to the minus 14 divided by 6.2 times 10 to the minus 9. Again, we want to make sure we punch it in correctly. So 1 exponent negative 14 divided by 6.2 exponent button negative 9. And looks like you should end up with a 1.6 times 10 to the minus 6. Again, it would be molar in this case. Question on that one there. Is this acidic, basic, or neutral? We're comparing this number here to this number here, and it is the H plus that is actually larger in this case than the OH minus, and it would be acidic in that case. Any questions on that there? And again, if you just kind of converted these into decimal form, you would have 0.1, 2, 3, 4, 5. This is the comparison in decimal form. And again, you can see this is a larger number than obviously this one with all the zeros. Any questions on that there? Okay, then we have one more OH minus, I think, here. So same calculation as the previous one. We're going to go H plus is going to be our KW value, which you always have. Again, not always given to you in problems, but you always have that number available to you. Divided by 8.1 times 10 to the minus 3. Again, pushing it in correctly here. 1 exponent negative 14 divided by 8.1 exponent button negative 3. It equals 1.2 times 10 to the minus 12 in this case, molar. That would make this one acidic, basic, or neutral, this one. Yes, I agree. That would be basic. There's 10 to the minus 3, which again is really only 0.008 versus like a ton of zeros. There are 11 of them before there. So in this case, the H plus concentration is less than the OH minus, or the OH minus is larger, and that would make it basic. Any questions on any of those calculations there? So again, a couple places where people kind of mess up on this is the punching into the calculator and then the comparison of the two numbers. Again, that negative really important. By the way, when you are asked a question of is it acidic, basic, or neutral for a particular solution, there is only one answer to that question. It cannot be acidic and basic at the same time. I've never really had anybody go acidic, basic, and neutral, but I have definitely had people say both for the same solution. So it's got to be one of those three choices. Any questions on that one there? I'm sorry. How would you punch it into your calculator? It'd be very much like the previous one. You would go 1, hit your exponent button, hit your negative button. Then you hit 14, you hit your divide button. 8.1 exponent button, negative button, and 3, and hit equals. Check that. Other questions on that? And again, a reminder, no multiplication with that exponent button, no like shift logs or anything like that, because we will be using logs very shortly here. So you don't want to be doing any of those crazy things. And again, a pretty good way to know if you're just really kind of punching it in incorrectly is most of the time this part of the number is all good, but this part is just off there. And that's usually a symbol as to how you're probably punching it into your calculator. Other questions on that? All right, so let's try a couple more here just to make sure. That one we just did. That one we just did. All right. We'll forget about the question it's asked. Let's just figure out what is the OH minus concentration here, and is it acidic, basic, or neutral? Okay, let's take a look. So here, OH minus, once again, 1 times 10 to the minus 14 divided by our 2.8 times 10 to the minus 5. And grab my calculator here. 1 exponent negative 14 divided by 2.8 exponent button negative button and a 5. Looks like a 3.6 times 10 to the minus 10. And again, molar would be the units. At this point, in comparison of our OH minus to our H plus concentration, we see that the H plus concentration is larger in this case, meaning that this solution should be acidic. Any questions on that one there? Any question? Yeah. So you want to compare the H plus concentration to the OH minus concentration. And basically whichever one is bigger is what it would be. So if the H plus, which is really the acid part of the solution, and the OH minus like the base part of the solution. So if the H plus concentration is a larger number, that means there's kind of more H plus in there and it would be acidic. If the OH minus concentration is the larger number, then it's more OH minus floating around the solution. It would be basic. If they happen to equal each other, they would be 1 times 10 to the minus 7, and then it would be neutral if they equaled each other. So in this particular case, really the only part of the number you really need to look at is just this part. So that's to the negative 5, and then this guy was to the negative 10. So to the negative 5 is a much larger number than to the negative 10, and that's why we know the H plus is larger and it would be acidic. Other questions? Yep. Okay. All right, I think we're gonna skip this one and we're gonna get into the pH scale here. So the pH scale is really the way that we sort of measure the acidity of a solution. The pH scale basically runs from 0 to 7 to a 14. From below 7 to 0, it's acidic. Above 7 to 14, it is basic. And truly dead on 7 there is neutral. The reason for that is the H plus concentration, the OH minus concentration, as we were just talking about, would equal each other. And it technically would be 1 times 10 to the minus 7, which technically would give you a pH of 7, basically. Now, there is some wiggle room there, but to just keep it straight for us in lecture, if it's not a pH of 7, then it's not neutral. Okay, so if it's above 7, slightly basic. If it's below 7, slightly acidic. That way there's no like, where's the gray area start and end? So we'll go with just dead 7 is neutral. Technically 7 is kind of your central point. As you go from 7 towards 14, you're becoming more basic. And as you go from 7 towards 0, you're becoming more acidic in that case. So to calculate the pH, you don't want to worry about any of this stuff that's written here. The pH is really this formula here, minus the log of the H plus concentration. And again, you could substitute H3O plus in there instead of H plus. This is basically the same thing. Now, if you have a display calculator, you're going to punch it in exactly the way it's written. You're going to hit the negative button. You'll hit the log button. And then you'll punch in the number, most likely using your exponent button. If you have a non-display calculator, this one and a couple of other formulas that we will see, you need to go backwards. So non-display, you got to start with the number, then hit log, and then make it negative and change it. So non-display, our display calculator. If you're not sure which type of calculator you got, all you have to do is hit log. If it says log, congratulations, you have a display calculator. Yes. If you hit log and it says error, congratulations, you have a non-display calculator. So those are your two options there. Yes, sir. Yeah, it should be the log base of 10. So it should say 10 on the bottom. There are a few calculators where maybe I've seen that you might as put 10. But so if you're asking, is it something like that? Yeah, or maybe. So it should be like the log base of 10 is really what it is. If you're not sure, just bring your calculator. We'll take a look at it. But if you just hit the LOG button, where a lot of people use for exponents, that's really just the button that you need for this one. Yeah. Other questions? Okay. So we use pH to help us determine is the solution acidic, basic, or neutral. And let's talk a little bit about significant figures and pH. The number of decimal places in a calculation like pH will equal the number of significant figures there are in the concentration value. So let's be very clear on this. We're going from significant figures in the concentration to decimal places, not sig figs to sig figs. So sig figs to how many decimal places you should have. So let us try one here. Make sure our calculators work. By the way, this is just not negative. It's just from PowerPoint. So if you have this concentration of H plus, why don't you calculate the pH to the right number of digits? So again, if you have a display calculator, negative log, and then punch that in with your exponent button. If you have a non-display calculator, you start with that number, hit the log button, and then hit the negative button. Okay, so let's talk about the number. Hopefully this should be the number that you see on your calculator, a 5. Yeah. So what we want to know is, how should we report it? Should we report it as 5? Should we do 5.0, 5.00, 5.000000000? Feels like a lot of zeros, that one. I was going to cross it out to start with. All right, so first off, everybody get the 5? Yes. Yep. Okay. So again, you would punch into your calculator. If you have a display, you would hit the negative button. You would hit the LOG button, and then you would type this in like we did previously, 1 exponent button, negative, and 5, and hit equals. Again, if you have a non-display, you would go backwards. You would start with basically the number, then the log, and then the negative if you're going the opposite way. All right. So what should the correct answer be? So to determine that, we want to look at the concentration value, which is over here. This number right here has how many significant figures? It has 2 significant figures, right? And it is these 2 right here. So the number of significant figures in the concentration is not how many significant figures we should have, but how many decimal places. So 2 decimal places here. So 2 to 2. So the correct answer here would be 5.00 would be the right way to record that. First off question on that there. Is this acidic, basic, or neutral, this one? It is acidic. It is less than 7, right? So if the pH is less than 7, it is definitely acidic. Any questions on that calculation there? All right, then let's try some here. Make sure our calculators still work. Let's calculate the pH of each of these solutions individually. And for each of them, is it acidic, basic, or neutral? So come up with 2. Let's take a look at number 1 here, looking for our pH. So our pH would be minus the log of our H plus concentration, which was given to us, 2.1 times 10 to the minus 5. So again, punching that in, depending on which way you're going, negative log and 2.1 exponent button, negative 5. Going to yield you a pH here of 4.68, it looks like. Again here, 2 significant figures in the concentration, 2 decimal places here in the pH value. Acidic, basic, or neutral, this one? This is acidic. It is less than 7. Yeah, so it's less than 7, so it would be acidic. Any questions on that one there? All right, take a look at number 2 here. Number 2 gave us not the H plus, but gave us the OH minus concentration, which means really to calculate the pH directly, you do need the H plus concentration. So one approach here would be to use KW. So if we use KW, that means our H plus concentration would equal 1 times 10 to the minus 14 divided by 5.9 times 10 to the minus 8. And 14 divided by 5.9 exponent -8 gives us approximately 1.7 times 10 to the minus 7 molar for our H plus. That then can go into our pH equation minus the log of it. And if I punch the numbers in right, try that again. 1.7 -7. And that will give us a pH of 6.77 in this particular case. Acidic, basic, or neutral. Yeah, it's just slightly acidic here, just below 7. Now, if you just punched it into your thing and you calculated it, and you got something like 7.23 by doing that. The good news is you did not calculate it right, but I guess that doesn't sound very good. But the actual good news is you're actually just like a slide or two ahead. What you had here was the OH minus, which means you could actually calculate what is known as the POH, which is minus the log of the OH minus. And if you did that, you get 7.23, which you may be saying, you know, how does that help me? It helps you because there's a really nice relationship. We will see that the pH plus the POH is equal to 14, which means you then can find the pH by taking 14 minus the POH, and that will get you right there going that way. So you can use that and actually not even have to use KW. It's a nice little workaround, if you will. But it's really important, as we'll talk about here in just a second about POH, is you should always look at the pH value to determine if it's acidic, basic, or neutral, because that is really what most people have in their head in terms of the scale. The POH scale is actually opposite. So if you have a low pH, you have a high POH and vice versa. So they're opposites of each other the way they run. Just like OH and OH plus goes up and down, opposites of each other, so does these scales. So earlier I was saying sometimes people say it's acidic and basic, the same solution, and this is the reason why. They will calculate the pH and go, cool, that's above 7, it's basic, and then calculate the POH and go, cool, that's below 7, it's acidic, and they will give both answers. So you don't want to do that. Always look at the pH value and use the pH scale. Any questions on that there? Okay. So that was the one we just did. Now the pH scale is based off of the log of 10, and as you change the power of 10 of the concentration, the pH changes by 1. So if you had 1 times 10 to the minus 3, the pH would be 3. If you change it to 1 times 10 to the minus 4, the pH would then go to 4 and so forth. By the way, if you have 1 times 10 to whatever it is, the exponent is the pH as long as the front part is just 1. It basically becomes it when you calculate the pH. As the H plus concentration increases, the pH actually gets lower because it becomes more acidic. So H plus goes up, pH goes down, and vice versa, obviously. So, you know, if the H plus concentration goes up, pH goes down, and the pH will go up as the H plus concentration goes down. And that's because the OH minus is really tied to them. OH minus would be going down in that case. OH minus would be going up in that case. So you'd have more OH minus, and it would be making the pH going up towards the basic region. Now, there's a couple different ways you can measure pH. Common way is a pH meter, which is a nice one. It gives you a nice digital display. It's really a voltage situation. You tell the voltage, like the machine, this voltage is a pH of 7, this voltage is a pH of 4. Then when you stick it in your your solution. It does a little calibration and figures out what the pH would be. Sometimes you use pH paper or color indicator paper. Ever like does anything with like a pool, and they could put the little papers and they change all the colors. You basically try to match up all the colors and stuff like that. Not the best. You're trying to look for colors and trying to match them up. So pH meter is much better way. Litmus paper doesn't really measure pH, but I think we talked about it earlier. Litmus paper will tell you if it's acidic or basic, and again, will not really tell you the pH. But you know, again, if you have red or litmus paper turns red, that usually means acidic. Again, will not give you the pH, but if it turns blue, it's basic. And again, you would need something like pH paper there to help you determine the actual pH. Here is the pH scale. And again, some things we see, we got blood, we got some cleaners, and obviously a strong base is in the basic range. These are all acids like vinegar, obviously stomach acid, and hydrochloric acid is also acidic. Pure water is right there around 7. Anybody know where water that is not pure would be? Is it 7? Yeah, it's like down in this region here, depending on how long it's been sitting out and stuff like that. So people are sometimes surprised, especially if they through pH meter goes, my meter broken. But no, water when it's sitting in the air picks up CO2, makes carbonic acid, increases the H+ concentration, and lowers the actual pH of that. So if you're really worried about pH and you're doing some type of experiments, a lot of times what they'll do is boil the water before you use it. That releases the CO2, decreases the amount of carbonic acid, and brings the pH kind of back up to more of a neutral pH and stuff like that. So we used to do that in experiments where the labs weren't maybe sealed as well. So we kind of jumped ahead a little bit a second ago, but there are similar scales to pH, and that one, the most important one, is the POH. And as I mentioned, the names really tell you what you need. If you're calculating the pH, you need the H+ concentration. If you're calculating the POH, you need the OH- concentration. It's really the identical calculation to pH. Again, you would punch it in the exact same way as you would punch pH. The only thing you have to remember is you're not actually calculating pH here, you're calculating the POH. Again, they do run opposites of each other. And this is a really, again, a very helpful relationship, as you saw there in the last example. It will allow you to maybe avoid using KW, or you can still use KW as you saw. They both will give you the same answer. So it does give you a few different ways you could kind of solve some of these problems. So putting our pH in here with it, putting our KW that we saw earlier. These are all good formulas that help you calculate things. There are a couple we'll add here. If you actually have the pH value given to you, you can get the H+ concentration directly from the actual pH value. And you do that by taking the inverse log of the minus pH. And you may be saying, what is the inverse log? It is basically on most people's calculators, there's like a second button top left, the shift button, and you want to hit the log button where it says 10 to the X, also known as how a lot of people do scientific notation incorrectly. This is actually what we use this button for. It is that one. When you hit inverse log on your calculator, most calculators will pop up like a 10 and a caret. And you want to make sure you make the pH negative, not subtract, but the negative button. You want to make sure that you hit there. You could also do that exact same calculation for POH. You could get the OH- concentration by taking the inverse log of the minus POH. Again, when you do that on your calculator, it will do a 10 and a caret POH. So for example, if we had our pH of 4.25 and we wanted our H+ concentration, why don't you give it a go, see what you come up with. I'll do it as well. See if we end up with the same one. Again, on your calculator, hit the second, hit the log, negative, and the pH value that's there, and then hit equals. By the way, if you have a non-display calculator, you got to do number first on this one as well. So you got to do number, then second log, and then actually number negative. So if you have a display, you're going to go second or shift button top left. You're going to go log. You're going to go negative. and then you're going to go 4.25. If you have a non-display calculator, you're actually going to go 4.25, hit the negative button to turn it into a negative value. Then you will hit the second button, and then you will hit the log button. So those are two ways you got to kind of punch those in. If you do it one of those two ways, again, if you have a display calculator, probably put a 10 and a caret, negative 4.5 when you do that. And where is it on this calculator? There it is, negative 4.25. And you end up with an H plus concentration of roughly here, it's 4.25, right? There we go. Type in the right number would be good. Let me just double check that real quick. I think I did, but all right. 4.25. There we go. You end up with 5.6 times 10 to the 1, 2, 3, 4, 5, negative 5 molar, or on my calculator, 0.0000562334. Obviously, again, may not give it to you in scientific notation. Okay. First off, any question on getting to that number there? Now, we talked about significant figures going into the pH value, right? So when we're going backwards like this, we follow the same rules. This has 2 decimal places, which means my concentration should have 2 significant figures. So going backwards and forwards on that, you want to kind of follow that rule in terms of sig figs and how many answers you should have. Any questions on that? So between these things here, you have a variety of ways you could solve for things. You could use KW to get to H plus or H minus and determine if it's acidic, basic, or neutral. You could calculate the pH of the solution. You obviously could calculate the pOH. You could calculate the pH or the pOH and subtract 14 basically to get the other guy, which is a nice quick way and a very convenient way to do it. And obviously, if you have the pH, you could get to the H plus directly from that number. If you have the pOH, you can get to the OH minus directly from that number. By the way, if you have the pH, you could subtract 14 and then get the pOH and get the OH minus that way too. So, you know, there's a lot of different sort of routes that you could go to solve for these things. As long as you choose a correct path, it all should lead you to the same number at the end. The key here is the punching into the calculator part of this, yes. So if you are having trouble with any of the punching in the calculators, make sure you come at some point and visit me or something during discussion. We'll figure it out on your calculators. Other than that, any questions on anything we talked about? Last major thing I said before is when you have both of these options, the pH and the pOH, always look at the pH to determine if it's acidic, basic, or neutral. Only one answer for that question. If you're off the lab, have a good lab. If you're off to